In this video, we'll extend our proof writing to include those with perpendicular lines. In the first example, we're given that lines M and L are perpendicular and that lines N and L are perpendicular. So the first thing that I'm going to do is go mark that in the diagram. And when I do that, I immediately notice that those have already been marked for us. Our goal, our mission here, is to prove that those lines M and N are parallel. Well, in looking at the diagram, I noticed that due to the perpendicular lines, angles 1 and 2 are right angles. All right angles are congruent to each other, making angles 1 and 2 congruent. And in looking at the picture, I noticed that angles 1 and 2 happen to be corresponding angles. So we've got a pair of congruent corresponding angles, which then forces our lines to be parallel. So that's the gist or the direction that this proof is going to take. I'm going to go ahead and start out with my first given. Line M is perpendicular to line L. I know that's a true statement because it's given to us to be a true statement. And because line M, the blue line right there, is perpendicular to line L, the purple one, I know that it follows that angle 1 has to be a right angle. And I know this because of the word perpendicular in the preceding step. So I'm going to go ahead and start out with that word perpendicular. Lines form. Notice here I've got a right angle, so I want to talk in my reason about right angles. All right, in looking at my diagram, the next thing I want to do is talk about angle 2 being a right angle. That doesn't have anything to do with the blue line and the purple line that intersect, but rather it has to do with this second given. So I'm going to go ahead and make line N a green line. And because it doesn't have anything to do with what's going on over here that I've written in blue, I'm going to start a new branch, if you want to call it, of my flow proof. So I'm going to go ahead and talk or discuss about lines N and L being perpendicular. That's because it's given to us that they're perpendicular. And again, I want to talk about that angle 2 being a right angle. And the reason that I know that it's a right angle is if I go back up here, that word perpendicular. So I want to start my reason by talking about the word perpendicular. So those perpendicular lines, as a result of those, we get the right angles that we have in the second statement. From our study of geometry now, we know that all right angles are congruent to each other. So we've got a pair of right angle, we've got a right angle over here, a second right angle over here, giving us a pair of right angles. Because those angles are both right angles, we know they have to be congruent to each other. And that's because all right angles are congruent. And then lastly, if we look at the diagram at these congruent angles, we've got these angles 1 and 2 that are congruent to each other. It just so happens that they're corresponding angles. And we know, based on our study of parallel lines, that anytime we have a pair of congruent corresponding angles, the lines those angles fall on have to be parallel to each other. So our last step here is going to be to use those corresponding angles to establish the statement that line M is parallel to line N. And this is one that you know well because we've done lots of proofs like this. So I'm going to say the congruent corresponding angles, which we had up here in this statement, make the lines parallel. Notice we have the parallel lines going on right here. All right, that's a nifty little proof. And whether you realize it or not, you have just proven your very first geometric theorem. All a theorem is a statement that can be proven using your definitions, your vocabulary, and your knowledge of geometry. So this theorem says anytime that you have two lines that are perpendicular to the same line, the lines are parallel to each other. So let's take a minute and write that down. Two lines perpendicular to the same line are parallel to each other. And now we can use that, because we've proven this to be a true statement, we can use that theorem in any proof that we want to write. Let's slow down for a minute though and think about what that means. We have given in the picture that the blue line is perpendicular to the purple. The green line is also perpendicular to the purple. So because those two, the blue and the green, are both perpendicular to the purple, what that means is that the blue one and the green one, lines M and N, have to be parallel to each other. I guess I'll go put the word other back in there. All right, so let's go ahead now, and I'm really excited because we'll see how we can use this theorem when we write our next proof. All right, this next one is also the last one for today. There is a typo in this proof right now, so I'm going to have you change it in your notes right now. This should say the proof is incorrect. The proof should say angle C is congruent to angle D. All right, I'm going to go ahead and start out with the givens and mark them into my diagram. I am, however, going to give you a few seconds to go ahead and read through the givens and mark them in your diagram first. All right, so hopefully at angle A and angle B, you marked those two right angles. So you were given that the line segment AC was perpendicular to line segment AB, making a right angle at A, and that line segment DB was perpendicular to line segment AB, making the right angle at B. Notice we've got two lines here that are both perpendicular to line segment AB. That tells us, or the theorem that we proved in example 1, tells us that segment AC has to be parallel to segment DB. So that's how we're going to use our theorem in our proof. And then, of course, once those lines are parallel, I might want to take my highlighter and extend those lines. I like to look at nice big parallel lines. Our goal or our mission is to prove angles C and D congruent to each other. But if we consider that red dotted line our transversal, angles C and D are alternate interior angles along that red transversal. Anytime you have parallel lines, the alternate interior angles along that transversal have to be congruent. So that's kind of the roadmap or the direction that this proof is going to take for us. But I'm going to go ahead and start out by talking about these two pairs of perpendicular lines. And I'm going to include those both in my given because I'm going to use those both with that new theorem that we learned. So line segment AC is perpendicular to line segment AB. Line segment DB is perpendicular to line segment AB. We know that both of those are true because they're both given to us to be true. And again, because they're both perpendicular to the same segment, we know because of the theorem that we proved in proof 1 that line segments AC and DB have to be parallel to each other. And our reason is that theorem. Two lines that are perpendicular to the same line and again, notice that in this preceding statement, we have them perpendicular to the same line, and as a result, they are parallel to each other. So now that we've established the fact that those two lines are indeed parallel, we can go ahead and conclude that angle C must be congruent to angle D. And that's an old one that you know because we've written lots of proofs along those lines. We've got those parallel lines, and anytime we have parallel lines, they have congruent alternate interior angles. And again, notice that We've got the parallel lines up here, and that's how our reason starts. We've got the congruent alternate interior angles, and that's how our reason ends. All right, so those are a couple nice proofs. I'm excited still about that theorem. Let's go ahead, and as always, I do want you to take a few minutes, reflect upon what you've seen, and in your own words, get your brain wrapped around what are the important takeaways that you need to recall from this video. And then you can go ahead, and this time I'm going to actually have you see what you can do with number 2. So try this one, just so that there's no doubt in anybody's mind about exactly what I'm going to be expecting the next time you come to class. And number 2 on that page, try this one also. Take them for a test drive. I will tell you that even if you can't get all the way through the entire proof, I want you to mark your diagram. You can all do that. I want you to get something written down on your paper. If it's wrong, now is your time to make mistakes. If it's wrong, we'll fix it the next time that you come back to class. But do put something down on your paper.